Okay, in the last video we looked at how the formulas for stresses in a thin-walled cylindrical pressure vessel are derived, and in this video we're going to apply those formulas by looking at example 20-1, in which we have a cylindrical compressed gas storage tank that has an inside diameter of 48 inches and a wall thickness T of 3/8 of an inch. 3/8 of an inch is 0.375 inches. The internal pressure of the gas being stored inside this pressure vessel, little p, is 150 pounds per square inch, or psi. We would like to calculate both the circumferential stress and the longitudinal stress. So for the circumferential stress, and that would be alpha sub Tc for circumferential. That's the subscript used by the book. Alpha sub Tc is equal to little p, the internal pressure, times the interior diameter, divided by 2t. So this is just going to be 150 times our interior diameter of 48. Now I need to make sure that these units are the same. This is 150 psi, and this is 48 inches. So I've got inches and inches, so that works out. Divided by 2t, and the thickness of the wall is 0.375. And so that equals 9,600 psi. And down here I've got inches as well. It's actually this inch and this inch that cancels out. And so the units of stress that are used here is just what the units of stress I get here. So I suppose all this didn't need to be psi. It was, and so it all worked out. 9,600 psi. Now one thing I forgot to check up here is in order for this answer to be valid, this has to be a thin-walled pressure vessel. Is it? So we have to compare the thickness of the wall of our cylinder to the radius of the cylinder. So we need to make sure that the thickness is less than or equal to 0.1 times the interior radius. So our thickness is 0.375. Is that less than or equal to 0.1 times the interior radius? If the inside diameter is 48, then the inside radius is half of that, or 24. So 0.1 times 24 is going to be 2.4. Okay, so is 0.375 less than 2.4? Yes, it is. So this is a thin-walled pressure vessel, so this formula is valid, and the tension, the tensile stress in the walls of the cylinder is 9,600 psi. Now, if we look at the longitudinal stress, alpha sub TL, that's equal to the internal pressure times the interior diameter divided by 4t. So instead of dividing by 2, this time we're dividing by 4. So we could go through the process of writing out all the variables, which I suppose we should. 150 psi times 48 divided by 4 times the thickness of 0.375. But if you're looking for a shortcut, we know that dividing by 4 is going to result in a number that is half of what it would be dividing by 2. So basically we could just take that circumferential stress, assuming we calculated it correctly, divide it by 2, and get 4,800 psi. This is the longitudinal. And again, this up here is the circumferential, or sometimes also called hoop stress. And that's it. One thing I want to point out, in the rare case that you have a spherical, so I'm going to kind of draw an axis going around like an equator. So let's say we have a storage tank that's not shaped like a cylinder, but instead is shaped like a sphere. No matter which way you slice through a sphere, whether it's vertically or horizontally, the cross-section is going to be circular in shape. So that is going to only have longitudinal stress. It doesn't have two parallel walls like a cylinder does. So, so that's the other shape of pressure vessel that these equations could apply to. In addition to a cylinder, they could also be applied to a sphere, but only this second one right here, only the longitudinal stress applies to a sphere. There is no circumferential stress in a sphere. And that's about it.